This is question number 5 on the sample test problems for test number 3. For each of the following functions, determine whether the function is one-to-one. If it is one-to-one, give an equation or graph for its inverse. Okay, so the first one is f of x equals x cubed plus 1 over 2x. So I don't expect that we know what that thing looks like, so let's go to the calculator. And I've typed that function in here. Note that you need parentheses around the top and the bottom. And so we'll graph this function. And remember, one-to-one means it passes the horizontal line test. That is to say, if there's any horizontal line that hits the graph more than once, then it is not one-to-one. But if no horizontal line hits it more than once, then it is one-to-one. So let's just take a snapshot of this screen. In fact, for good measure, let's also take a snapshot of the thing that we typed in. And so with these two things side by side, we'll just draw a horizontal line and say, since some horizontal line hits the graph twice, this function is not one-to-one. Part B, g of x equals the square root of x plus 9. I'm actually hoping that we know what this one looks like without graphing it on the calculator. Feel free to confirm this on the calculator. But what I want to do is think about graphing first y equals the square root of x. And I'm really hoping that we have a sense that that's this graph. And then the next thing I want you to understand is that we're replacing x with x plus 9. So take a moment to think about what that transformation does to the original graph. So hopefully we understand that replacing x with x plus 9 moves the graph 9 places to the left. So it's going to start over here at -9 and then go up, something like that. And so looking at that red graph, I can think about this idea of horizontal lines and know that it passes the horizontal line test. So this graph passes the horizontal line test. So G is one-to-one. All right, so the goal, now that we know that this function g of x is one-to-one, is to find a formula, an equation for its inverse. So this is that little process that we need to do. First thing I'll do is replace the g of x with a y. So we go y is equal to square root of x plus 9. Then we change all the y's to x's and all the x's to y's. And then solve for y. That's the hard part. So solving for y in this case means, let's see, I'll write it again. So right now the y is buried inside of a square root. So we're going to square both sides. And so we get x squared equals y plus 9. And then to solve for y, subtract the 9. So y equals x squared minus 9. And then finally replace that y with an f inverse. So that's the equation for f inverse in this case. One little detail, and I don't know how concerned I am with this detail because we didn't really talk about it too much in class, but let's see, the range for this function here in red, remember the range is the y values. So the range for this guy, let's see, this function here starts at y equals 0 and then goes up forever. So the range here is all the y's bigger than or equal to 0. And if that's the range for g, then that must be the domain for g inverse. And so we kind of have to say that the domain here is all the x's bigger than or equal to 0. Remember, domain becomes range, and range becomes domain. Like I said, I'm not certain that I'll make a big deal out of that, but I just wanted to be complete. And then finally, part C, it says h of x is graphed below. So we want to, in this case, come up with a graph for h inverse. So first thing you need to do is draw on the line y equals x. And then our job is to reflect the original graph over this line. I like to pick a few points. For example, this point right here, which is at 0 and say negative 2.5. Change those x's and y's, and we get this point over here, negative 2.5 comma 0. And we'll pick this point over here, 5 comma 2. It becomes 2, 5. And then maybe one more point. Let's see, I'll pick this guy right here. Say this is negative 5, negative 4.3. And so if we change those, we get negative 4.3, negative 5, something like that. And so our job is to just connect these dots as best we can. So something like that.